And I'm live. That is pretty cool. Today is 11th of January 2026, Sunday, and let's just start working. On the website, there are just two objectives for today. Yep. First one is to add symmetry to the organisms. This is how one of the organism looks right now, and this is not very symmetric. So I would like to add some symmetry along the x-axis so that, like, if you flip the thing horizontally, you have the same thing. So like this. And the blind watchmaker Richard Dawkins made shapes like this, and they are all symmetric along the x-axis, along the y-axis. So yeah, this is one thing that we have to add, and second would be to adjust the aspect ratio, because here we have, I think, 300 by 300 SVG image. And yeah, when like later on we will be having a bunch of these organisms in a single frame, so we do not want them all to take up any arbitrary space. We want them to like shrink in some space and like just have that much space. Yeah, right. Okay, but I think for the aspect ratio part we can do some maybe there is a library which we can use to shrink and not, yeah, to shrink the whole image and not change the relative size, and not change the relative length proportions of these shapes. Like if we are mm, uh, reducing the size of this thing, then the aspect ratio should of the shape should remain same, and that is what we are aiming for. So yeah, let's add some symmetry to this thing because this is not very symmetrical. There is some update in Vim plugins. Okay. Hmm. Harpoon. This is our like initial DNA, the DNA for this thing that we see here. And if we change this a bit, yes, the shape also changes because, yes, of course, DNA. Yep, shape does change. Okay, we need to add some symmetry to this. Print SVG. This thing takes in lines, but no, we have to make a change in this make SVG. This function. This function takes in DNA and it returns a bunch of lines which will define the organism for which this DNA is for. So we have to make our changes here. And what should we change? Should close. So right now, if we have, like, initially we have just a single line, and from both the ends of this line, if there are, let's say, two branches which should come out of this line, then we divide the thing, this whole angle, into three parts: one part, two part, and three part, and make two branches here. But that does not lead to symmetry, because when we do the same thing here, uh, and let's say we need to give only one branch, then we will make one line here and one line here, and like the thing at the end is not symmetrical like here. So we need to add some symmetry, for which I think we can take a, for the first layer, when we are making the this first branching. At that point, we can just take this angle 180 degree and we can divide this angle and make our whatever branches there are along this axis, and always we will just make these changes or divisions on one side, and then when we are forming the whole final image, we will take all of the lines on this axis and reflect them along the y-axis and make the same structure on the other side. So I think that would be fine. We will have some symmetry there, like that. Yeah, so we'll just make these lines for one side, and when we are forming the final organism, we will just reflect all of these lines along the y-axis and have the same thing along the other side, and hopefully the images would be symmetrical. Okay. Along, yes. Yes. And here, no, two layers, two. Yeah. Yep. This dot front, yep. And if DNA dot layers equals or greater than equal to 2, in that case, we have an angle of 180 degree. Yep, we have an angle of 180 degree. Right. In which case we have to copy paste all of this for each line. No, there are not a bunch of lines. There are only two lines. Yep. Sure, yes, we have to copy all of this and put this here, or we can handle this inside this loop, but at some point we can check 180. Yes, at some point we will check here. Line x pi by 2 first angle between is base angle plus j into angle space. That is correct. Angle space is 2 pi. No, we will change it. Its angle space will change. If I equals 1, if we are on the first layer, then angle space would be, originally it is 2 pi, but here it would be pi. Okay, that might make some change, and it does. It does. Okay. Okay, that is correct. That is correct. We just have to, yeah, we just have to add more shapes. We just have to reflect this figure on the y-axis. Let's increase the number of layers. Hmm. Base length is, let's say, 1, length delta is also 1, and that is not very good. That is a lot of layers. 6 minus 1. Okay. We have a lot of branches. Let's say one branch. Angles is 3. That is a square shape. Length, angles, del branches. That is correct. That is correct. Okay, we are messing up somewhere. Yes, let's keep decreasing the total angle. We want shapes like this. We want shapes like this. These are very good shapes. These are, yeah, more complicated than these, than this simple lines. Yeah. Const angle between J into angle space. Yes, I think, yes, we should decrease the angle space as we move forward. Angle space initially, should we make it 2 pi? No, I think we should decrease the angle space as we move forward. Yep. Base angle plus J into angle space. Yes, and angle space would change. Yes, yes, yes. Okay. Angle space, initial angle space. This would, yes, this would not work. Okay, base angle is angle space. Base angle is angle space initially. Okay, and the number of branches is also changing, so we also have to update angle space. Yes, makes sense. Which is updating at the end here. We have the front and then the length, DNA, symmetry. We need to add symmetry. New front, which is a list of lines. Yep. Front equals new front. Yes. Everything else is correct. Okay. For when we are making the, like, when we have our initial one line, we can think of this angle and make new branches by dividing this 180-degree angle into some parts, and then on the subsequent branches, how much maximum angle should we take? Shit, yes, we can just think of this line and take this as the base angle towards right, and then divide 180-degree. Okay, that is cool. That is cool. And our DNA will be able to change this base angle, not too much, not too much, but yes, not too much, only a little bit. Yep. Our DNA base will be able to change this, only the angle of this thing by some degree. Yes, that makes sense. That makes sense. That makes sense. Yep. Okay. So we have to see how we interpret the base angle. DNA dot angles divided by 10, which gives us the ratio, not multiplied by 2.5, nope, but by pi by 2. Mm, yes, pi by 2, that gives us, yes, it can only, base angle can only change by 90 degrees. Okay, cool. Yep, cool. And then here, length is fine, angle space we have to change. Angle space, pi, yes, angle space, pi minus angle. No, we have 180. Yep. And pi, yes, yes, that is correct. Yep. And then base angle would be, and nope, not angle space, base angle would be angle space plus plus angle. Okay. And here const line between angle would be base angle plus j into angle space. So yeah. Sure. If we are not using angle anywhere here, 12 by 90 angle space plus angle. Yes, angle between these two lines would be this. Let's see. We have one line, and then we have the second line, and we have this angle. Okay, and we are saying this between angle is this j into angle is space, base angle is angle plus base angle, which is, okay, which is this. This is not right. J plus j into base angle. Const between angle equals base angle plus j into angle space. Base angle, first angle. Hmm, that makes sense. And second angle between this. No, this is not right. We have one line like this and another line like this, and we know this angle, right? Yeah, this is not very good. Length is updated correctly. Base angle is okay. Angle space, the angle between the branches, this is also correct. And base angle is this angle, which is this angle that this new line is going to have with the end of the previous branch. Const between angle means base angle plus j into angle space, which is correct. Yes, j into angle space, because initially j is equal to 0, so yes, that is also correct. Between angle is this angle between these two lines, and yep, between these two lines, first angle is the slope of this line, which is this slope of this line, this angle, and second angle is this. Second angle is between angle minus first angle. Between angle, this minus first angle. Because yes, slope of this thing plus slope of this thing equals relative slope of this. Okay, I think this should work. This should work. No, it does not work. No, this is not symmetric. Nope, this is not good. Nope, this is not good. New front, x and y. Nope, 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 nope. This is not good. We should have two lines here like this, not this way that we are having them. This angle, okay. Slope this upon this. Mm. Now this seems more realistic. This to this, okay. And yep, this one angle, this and this. This upon this is this angle. And yeah, let's tilt this a bit more for realistic reasons. This and here this, okay. Angle between two lines, y equals mx plus c. Angle between two lines is tan theta cos parallel perpendicular. No. Here in the calculation, what we are doing is we are from this angle subtracting this angle, and we are saying that the angle that we get is this one. And no, it is not working correctly, because why would it? Let angle is space, math dot pi divided by branch space. This should be working. Yes, that is wrong. That is clearly wrong. Yes, that is clearly wrong. But this is 9. Yes, that is wrong. Yes, that is wrong. Length 6 minus 1. Yep. No, that is wrong. That is wrong. That looks like a flag. Del branch. Yep, that is wrong. Control X. That is a little bit better. Angles 1, angles 2, 3, 4. No, let's change, remove the whole fact that we have some other angle like this. Yep. Let's make this pi by 2 by force. And we do have some kind of symmetry, but no, that is wrong. That is not the one that we're looking for. 90 degree. Yes, 90 degree. Yep. And then length. Okay, here angle space is pi, which is 180 degree, divided by this. Okay, base angle is angle plus angle is space, which is also correct. Base angle is angle plus angle is base. Branches angle between is, this is also correct. Yes. Yes, this is also correct. Right. This whole angle, shit, yes, this whole angle here is equal to, this angle is 180 degree. This brown angle is 180 degree, and this angle is something. And yes, we can calculate this angle. Yes, we can easily calculate this angle, but that would be just 180, 180 minus, uh, yes, this whole original blue angle minus 180 would be equal to this angle, and we also know this angle. So the final answer would be, shade this, let's say, first angle, and this is angle, let's say, second angle, and let's say this is angle number 3. So angle 1 plus this angle is angle number 2 minus 180, angle number 2 minus 180, it is this angle, and this angle is, let's say this is third angle, let's say this is x, the angle that we are looking for, x, and we want this angle is 180 minus x, so plus 180 minus x equals 180, the sum of angles in a triangle. We can cut this, and we have x equals angle number 1 plus angle number 2 minus 180. You can use this formula now. Yep, x would be equal to this, but this would only be true if the angle that we have is greater than 180 degree. Yep. If it is smaller than 180 degree, what if our one line is this, and what we are doing is we are creating a imaginary line here like this, and we are dividing from this, and we are dividing these angles equally, this and this, and the angle that we do have is this, which and this is 90, so 90 plus this angle, which is not 180 degree, which, yeah, it is this angle. So if the angle is okay, if the angle is greater than 180 degree, then we can use this formula, but if the angle is not greater than 180 degree, in which case if the lines are like this, if the lines are like this, then the angle that we have is this one, smaller than 180 degree, and yeah, we have this angle, and we want to find out this angle. Wait, this, let's say, is angle number 1, angle number 2, and let's say this is x. Then in this triangle, we have angle number 1, which we directly have, plus this is 180 minus angle number 2. Yep, 180 minus angle number 2, and this angle would be 180 minus x. 180 minus x equals 180. 180. X would be finally equal to angle number 1 minus angle number 2 plus 180. This is the formula when this second angle is smaller than 180, but if the angle is greater than 180, then this is the formula. Just shit. Shit. Okay, so we have to just take the modulus of this part. Second angle minus 180. Shit, yes, okay. Angle between equals, yes, angle between equals this. And let's make this lit. And yep, angle between is this. Between angle equals math dot absolute value of between angle minus pi, which is 180 degree. Okay, we do see some change, and we have the first angle. Yep, and the second angle would be just shit. The sum of these two. That is kind of not right. Yep, that is not very right. This thing, if we change the number of branches, no, that is wrong. That is wrong. That is certainly wrong. Hmm, Second angle plus between angle. This should work. Angle number one plus angle 180 minus angle 2, 180 minus angle 2 plus this first plus 180 minus angle number 2 plus this angle is 180 minus x is totally equal to 180, and at the end x would be equal to 1 minus angle number 2 plus 180, which is exactly what we are using. Yeah. Okay. Yep. This should have worked. Cos and sine. Yes, we are also updating the value correctly. It's okay. That is wrong. That is wrong. That is wrong. Branches two. Where are the two branches? Okay, we are not seeing enough branches. Yep, we are not seeing enough branches. Yep, for branches. and the number of branches does not change. Delta is 0 between angle is correct. Yes. No, it is not. For line on front, yes. Angle space is correct, and between angle is angle space plus angle which is 90 degree. Okay, if I equals 1, then base angle would be equal to, no, base angle would be fine, just angle space would change. No, both of them would change, yes, it should. If I equals 1, if we are at the first layer number 1, angle space would be equal to, angle space is correct, angle space is correct, 180. Yes, we are always dividing by 180. Base angle equals angle space. Okay, that is much better. That is much better. Yes, that is much better. Yes, that is much better. Shit. Yes, that is much better. If we increase the number of layers, that is not so much better. Yep. For this part, and this is cool. This is cool. This is working exactly as we want. 3, 3. Yes, and the angles are also dividing correctly. This angle equals this, which equals to this angle here. Hmm. And okay, angle space plus angle. Angle is 90, right? And angle space math dot pi divided by branches plus 1, which is correct. This should work. Yep. Shade. Maybe, maybe. That's not absolute. And here also the same thing. That has something to do with this. With that, no. It is also not working. Wait, maybe it is working, but the first line is exactly at this point, and we are not able to see it on the top of the parent line. Yep, TypeScript. Hello, that's why. Let between angle, base angle plus j into angle space initially. Yes, base angle would be fine. Mm-hmm. Angle is 90, which is pi by 2, math dot pi by 2. So at least we are adding 90 degrees, but we are not seeing 90 degrees. Plus angle space is, yes, it should be correct, but it is not. New front equals front angle. Okay, we are changing the angle here. Okay, shit, we are changing the angle here. There is no change. Branches, new front. Length is changing. Uh, hello. Like, shit. Soul person watching me. So, that's why this is what we are trying to do here. We are making not from after Game of Life, we are making evolution, right? Something like this. Look at this. Beautiful figures. Gene 1, gene 9, different genes determine different things, and this looks beautiful, but this does not look beautiful. Yeah. We want beauty. Let angle between equals mm, minus pi. Math dot pi is correct. J into angle space. Yes, everything seems correct. DNA dot branches. Yes, everything seems correct, but it is just not working. But if I manually add the thing, plus math dot pi by 2. Okay, we do have something now. Math dot pi. Okay, now this is correct. Now this is correct. But no, it, these things are not depending on the angle given to them by this line, but they are all same. All of these like pairs of this acute angle, they are all same and they are not changing with the baseline from which they are coming out of. That is not very good. Hmm. Math dot pi plus something. Okay, angle. Hmm. Is pi by 2. 180. What is the wrong part here? Console.log angle, if I equals this, base angle changes to just angle space which is cool. And if we remove this here also. Okay, okay, this is kind of wrong. Angle space. Okay, our formula for calculating the next place where the line should be seems to be wrong. X2 line dot end plus cos and sine. Math dot abs. Oh yes, yes, that is good. And here also the same thing. Math dot abs. Hmm. Okay, that is something, and if we here add some angle, and no, that is not right. Hmm. Pi by 2. 2 into pi. It's a full degree rotation. No. For okay, base angle. Angle is space. Yes. Angle space. Okay. Right angle space. Okay. Branches is 2. Make it 1, and layers also decrease by 1, and plus 2. Hmm. And pi branches we know is 1, 1 divided by 3, 1 by 3. Pi is 180 degree, 180 degree divided by 360 degree, 60. So this is at 60 degree, but 60 degree to what? 60 degree. I is equal to 1 in this case. Base angle equals 60. Base angle equals base angle, yes, still 60 degree. Between angle, 60 degree to what? This should be 60 degree to this angle, like this, but it is, I think, 60 degree here, because if we decrease this by 1, or wait, increase this by 1, now decrease and change branches by 1, save this also, yes. So 60 degree is this. Okay, this is a 60-degree thing. Okay. X value here is decreasing and Y value, shit, Y value is also decreasing. Mhm. Yo, hello. Today we need to add symmetry to this thing so that it looks a little bit better. And shit, my phone is going to die, I think. And same for the laptop. 14, increase the branches. Yes. This is not shit. We are just getting something, and this is not beautiful what we are getting. Mm, Restart, push. Branching off at the first layer is the only thing that is fine. For the other layers, it is not working. Let's see the angle, second between angle. Console. Okay. Uh, Between angle. Okay. We have the between angle as these values. If which is in terms of pi, so uh, multiply this, so pi equals 180 degrees. So 1 unit of pi equals, yeah, 1 unit of pi angle equals 180 divided by pi. So yeah, multiply this by 180 divided by math dot pi. Okay, we have an angle at 90 degree, one angle at 45, and one angle at 135 degree. Okay, okay, and this is the 90-degree part. So it is taking the angle from the left side. Okay, okay, and if we say the if the base angle is correct. Okay, okay. 60 and 120 degree. Okay, and if we increase the branches, no, not the branches, but the layer, one line is at angle 30 degree and one is at an angle 29. Okay, that is why we cannot see them. Why is that? Because angle space is not too much. log angle space is angle space angle angle space is 1. Yes, angle space is 1. But 1 in not degrees, but in terms of pi. Base angle equals angle space. Yes. Angle space 180 divided by math bar pi into angle space. Angle space is 60 degrees, which is what we should see, but we are not seeing that. Base angle space, yes. Between angle space, between angle is only increasing by point zero zero something. Why uh, j into angle space, base angle. Let's see the base angle then. Between angle is base angle into angle space. Mhm. Base angle is somewhere into base angle, and we see that base angle is 150 degrees. Okay, which is being defined here. Um, j equals 1, angle space, base angle increases. Between angle was 60, then it became uh, between angle was 30, 30, 29, 30. It is not good. Hello. I still cannot understand why you are trying to use React as graphics library, STL or something, because I want to make this on web. This was the last thing I expected when you said that you would be focusing on web development this year. Yeah. Actually, Kakashi. Shit, now you are actually Kakashi. You are a bit hatke, I would say. Why not use CSS for graphics? Shit, that would be a bit too low level. Not low level, but Tailwind is nicer to use, more convenient. But here the thing is more logic. Shit, the problem here is not with React, it is something else. Mm, mm. Angle is, well, first of all, the problem is I have not named these variables meaningfully. What does angle space even mean? Angle space means what is the space between each branch. But yeah, that is on in the name. Hmm, hmm. Hmm. This angle is the angle between two lines, and this why is this only changing a little bit even when angle space is a big number, because I'm subtracting pi from this. No, shit, that might actually be what now? Shit. Shit. Okay. Okay, here the problem is now uh, that these lines, this these pairs are not changing their angle with the line that they are branching out of. They are like all of these four acute Pac-Man like lines, angles, they are in the same orientation and not changing with the base of the line that they are coming out of. That is not very good. So make it in something else and use WSM or just use React. I mean, one technically can, but it will be rendered on CPU and not in way you want. And things like shaders, textures, and materials won't be possible. So nothing complex can be made. I'm making lines. I'm just making lines. So yeah, nothing complex is needed here. Lines are cool. Hmm. Line dot end y. Wait. Yes. Go out into the front. Yes. Yeah. Second angle. Okay. And second angle is changing because wait. Shit. Wait. That should change something. Yes, that has changed something. Divided by maths dot add shade. Okay, that was a bit stupid, I think. Okay, that is much shit. That is not just much better. That is exactly what we were looking for. Shade. Okay. Increase the number of layers. Yes, that is good. That is yes. That is improvement. That is improvement. Now, these new branches which are branching off, they are changing their orientation depending on the base line that they are coming out of. Not on the third layer, but here on the second layer, they have changed their orientation. So that is cool. Yeah, yeah. Mm, that is cool. That is cool. Yeah. Okay, that is cool. That is cool. That is cool. Wait, we have to choose this. Yep. Okay, and we need to give some angle. Base angle we have already fixed at 90 degrees between angle divided by Yep. WebAssembly basically writes to be executed in browser much faster than JS, primarily used for times when heavy and fast computation is required, and though has a bit of overhead. And when we were doing Dart, I guess we did some assembly stuff, and that was cool. The heavy tasking it performs won't make that overhead something big. That is cool. It needs a lot of maths. I mean, this is basic maths, but yeah, I've not written the code very beautifully. Okay, now these lines here, they are not coming out correctly because like this central line between this line and this line should align with this line, baseline that they are coming out of, like it is happening here. The line which divides this and this into two symmetrical halves is parallel to this line here. Or like if we extend this line, this these two lines will be divided equally, but here it is not happening. Yep, yep. Here it is not happening. Why is that? Base angle equals angle is base. Yes. Uh, yes. First angle plus between angle, which should be math dot abs. And what do we have now? We have something strange shit. Okay, we have to revise our formula again. Yep, we have to revise our formula again. We have this angle, we want this angle, and we have one of the angles here. Okay, we can always M1, M2. We don't know whether we have this angle or we have this angle. We don't know. Right. So let's say we will always get this angle. There is always going to be one angle which is smaller than 90 degree and one angle which is greater than 90 degree, or they are both equal to 90 degree in one particular case when they are both perpendicular to each other. So like this or this. Okay, but then we are losing the information which line is the base and which line goes up. Hmm. Yep. Because if we are saying we have one line whose whose slope is something, and then we need to find the angle of a line which gives their combined angle some acute small angle, then we could take this line or we could take this line. They are both giving the same angle like this. Yep. So we have to clearly define what angle we do have. Okay. Okay. We have a single line, right? We have a single line and we are giving it a buffer, let's say, of 90 degrees, which is pi by 2. Pi by 2 of buffer, and this remaining angle, this remaining whole space of 180 degree, we are dividing that by the number of branches plus 2. If our number of branches 3 is if our number of branches is 2, then we will divide this by 3, and we divide this thing into 3 equal parts: 60 degree, 60 and 60, 60, 60, 60. So our new branch should come out like this. Okay, so the angle that we will have is going to be this base angle plus 60 degree, and 60 is pi by 3. So 90 plus 60, 150 degree in total, right? And this is 60. So first line should be at an angle of 150. Second line should be at 210 degree. Hmm. So the angle is like this. Angle is like this. Yes, in the yes, this is the positive direction. Angle is in the positive clockwise direction. Yes, okay. With the baseline. Okay. Angle between is correct. If we remove this, hmm, we have something like this, which is not very right. Yep, not very right. Hello there. Slope. Yes. And here we are doing this something. Okay, so we have one line and wait, we have one line clockwise, with the angle being clockwise like this, like this. We want this angle. This is the x-axis. Okay, we have this angle number 1. Let's say this is angle number 2. Camera. Just 1 second. Up. This is angle number 2 and this is x, then 1 plus 2 plus 180 minus x equals 180. So x equals angle number 1 plus angle number 2. This angle equals the sum of this angle plus this angle, which is what we are doing, this angle plus this angle. this angle plus this angle only if this is this. But what if we have this angle? Base 90, some line goes here at an angle of 60, like this, and this goes on like this. Yes, we do have the inner angle, this angle, inner angle here, 150. But wait, shit, that is like completely shit. Okay, if this is the angle that we have, and we are saying that x-axis is somewhere, this line has a slope of something, and we want this slope. Shit, okay. The way that we are forming the drawing here was misleading our calculation. Okay, we need a general solution then. Both the lines can be in any which way. We have angle of one line, we have angle, we don't have angle of another line, but we do have the angle between these two lines. Okay, angle between two lines. Yes, tan theta m1 minus m2 1 plus m1 m2. Tan theta equals m1 minus, let's use first this terminology, first, second, and x. So 10 second equals first minus, and it depends, m1 and m2 are dependent. Yes, the tangent of the angle is this. Yes, acute angles use this. Okay, we will use both the formulas and see which one is correct. This minus x upon 1 minus plus first into x, tan theta. So x, we don't know x, 10 of the second angle plus 10 of the second angle into first into first plus 1 whole thing into x equals the first angle. Therefore x would be equal to the first angle divide the first angle minus tan of the second angle divided by 1 plus first angle into tan of the second angle. Okay, which is okay. Okay, so second angle should be equal to first angle minus the tan of the second angle. So between angle method of tan, this whole thing divided by 1 plus first angle into math dot tan of the between angle. We have something and shit. No. Okay, we are seeing correct divisions here. here and here, kind of, because this angle between these two lines is smaller than it should be. This is smaller than 60 degree. It seems like it happens for the second line of each branch. The first line is, yeah, first line is correct. But that basic math, yes. I think it will be much easier if you generalize all angles with respect to x-axis and then make the lines. I think now with this, it is correct. First angle, yep. Now it seems correct. This first angle is with the x-axis and second angle is also with the x-axis, and this angle between is between the two lines. Base angle plus how much more space we want. Angle between is base angle plus how much space we want here. This theta something. Hmm. This seems cool. There's branches. What if? Okay, why is it going in one direction? It should not go in. These should like just go forward. They are going down. Angle between first angle and second angle. Angle between that would be 180 divided by math dot pi to convert it into degrees into between angles, not angle between. And first angle, angle second with the wrong spelling, second angle. Hmm. Angle between 180 degree. Yes, yes, 180 degree, 180 degree. Yes, correct. That is, yeah. And first angle is 52. Angle second is also the same, which is correct, which is correct. So the slopes of both the lines are same. Yes, because they have an angle of 180 degree between them, but the points are not moving correctly forward. Math dot cos into second angle into length. Yep, the points are not moving correctly. Because why are they not moving correctly? Precision. We can check this. Uh, let's say new new slope equals y2 minus y2 minus line dot end dot y divided by x2 minus line dot end dot x and console.log new slope is equal to 180 divided by math dot pi into new slope. Yeah, it is different. It is different. It is different. Yeah, the slope is different. Slope is different. Slope is different. It is not correct. This is some problem with the precision. And what is the angle for the second line if the first one make theta angle? If the first line makes theta angle like this, the second line makes this base angle plus 2 theta. This is also theta. So if this angle is 90 plus theta, then this angle is 90 plus 2 theta. Yeah. The spacing here is constant. Just the number of branches, 180 divided by the number of branches plus 1. So in this case, theta would be 60, just like that. Okay, the slope. So now here we have a point. The way that we are calculating the end points for the line is we have a point and we have a slope, some angle, and we are and we want to move from this point in this angle with this slope some L distance. So we are taking the y component of this by L into sine theta, and the x component is L into cos theta, and we are adding that to this. This is L cos theta and this is L sine theta, and we get the ending point. But when we are taking the slope of this new line that is formed, this is different than the slope, than the direction that we moved into. Why is that? New slope is different from the slope that we gave it somehow. Which is not very cool. Y2 minus y1, x2 minus x1. Yes. And this is happening for all of the angles. Here the angle that the direction in which we moved was 42, but the new slope was different. This is probably happening because of precision problems. Yes. So maybe instead of working with pi, we can work with something. Shit. How to get double precision in JavaScript? Can we get double precision in JavaScript? Or already double precision in JavaScript? Shit. Where is this double precision? Maybe we can work with degrees, and when we are calling these functions, we can convert that degree into pi, into like radians. Not 2 theta, that is 180 minus 2 theta. Whole angle should be 90 plus theta for the first line, and 270 minus theta for the second line. If you want symmetric division, this would be when I only have two divisions, when we only have two branches coming out of the last one. But if we have three or more in that, and this would be symmetric because the theta angle, this is equal to 180 divided by the number of branches divided by the number of branches by, oh sorry, 180 by branches plus 1. So if we have three branches, then the angles in which these three branches are dividing this whole 180 degree into these angle are going to be equal to each other. So it does not matter if I am doing 270 minus theta or 90 plus theta then plus again theta plus theta again, because these angles are equal to each other. Now the problem is precision. The new slope is not equal to of the slope in which we are moving forward. Yeah. New front dot push start and yes, that is the reason, since here the original slope that we moved into and the slope that we are getting afterwards with the direction in which the point did actually move, that second slope is higher. That is why these lines are going downwards, and yeah, that is not good. Precision problems. Yep, precision problems. Let's work with degrees and we can convert everything later on into radials. Angle is 90 degrees. 90 degrees and DNA dot layer. Nope, nope, nope. Angle space is pi. Nope. It is 180 divided by branch plus 1, and angle is angle space plus this. Yes. And yes, this thing first angle comes out in not degrees but in radials. So we will multiply this by pi and divide by 180. Multiply by math dot pi divided by 180, or better still, first multiply and then divide by 180. And in this case it should be 90. Second angle is, yes, here we are using angles, tan theta of between angle which is in degrees, and we have to now convert this into radians from degrees into radians, which is multiplying by 180 and divided by math dot pi. Divided by, multiply by 180 divided by math dot pi, and here the same thing. Shit, I messed up. I messed up. We have to do this in the opposite direction. Yes. Let's print this. Multiply by math dot pi divided by 180. Math dot pi and divide by 180. And the same thing here. Divided by 180. Okay, that is good. Math dot pi divided by 180. Shit, that is good. That is good. That is good. That is good. Okay, that is working. That is good. Multiply by math dot pi divided by 180. Shit, okay, now we do not have anything anymore. We do have something, but that thing is not correct. Mm. Okay, that is not correct. That is wrong. Uh, okay, so theta depends on the number of lines, but is still like if there are two lines, then the first line will make 45-degree and the second line will make 180 plus 1. If there are two lines, then the first line will then theta will be equal to not 45 but 60 because we are dividing 180 by 3. So 60, if there are three lines, then 90 plus 45. 45 if there are three lines, then yes, then the angle would be 45 and 180 plus 45. Yes, 90 plus 45 and yes. Wait, no. Yes, yes. In that case, this would be the. Bro, my math is wrong. No, this is fine. This is correct. In the first line would be at 135, second line would be at 135 plus 45, 180, and the last line would be at 180 plus 45. This is shit. What are the angles now? We are getting negative angles and stuff. Yes, new slope, accept new slope. These angles are way too small. Angle between 239. Yes, these angles are way too small. Second angle, first angle, these are small. This thing, shit. Yes, because this should be 180 divided by math dot pi, and no change, it seems. First angle is still bad. And 280 by pi. Line dot end x minus line dot start dot x. Let's take all the things with which we want to divide at one point, and here we should have line dot n dot y minus line dot star dot x. My bad, not y but x, and divide this whole thing by this, and still wrong. Angle first is still small. Yes, it is still wrong. First angle equals 90. No, let's go back to angles. Let's go back to using pi, radians. Hmm. This is what we have. 1000. Yes, that is a big slope. Hmm. Okay, I think we can work with this only. And yeah, I think we can just move forward and work with this. Let's add symmetry in the sense of if we flip the whole thing on the y-axis, we have the same thing. Let's add that symmetry. So whenever we are pushing some line here, we also need to push its opposite line, which is flipped on the y-axis, in which the start and end points would have the same y coordinates, but their x coordinates would be negative of what is here. New front dot push, or let's copy this thing, and negative. Hmm. Well, that is symmetry. That is symmetry. The images are not very sophisticated. If that is symmetry, that is symmetry. Hmm. Okay. Uh, let's. Who is forming these images? Make SVG. Pixels per length. Yes. Let's make this 10. Yes. And here increase the length. Maybe like okay. Shit. There was I think a checksum. Yes, we will do this later on. Yes. The checksum about length. Yes. Not minimum. Just update the length. Yeah. Okay. 20 and decrease by 5. Okay. Uh, Change that. Increase the layering. Mm. 5 minus 10. I think we can work with this. These images that are formed. I think they are fine. They are fine. Not really fine, but yeah, it works. This is somewhat like what we were aiming for. Like, look at this and look at what Richard Dawkins had. Mm, this looks much better. This does not look better. Cool, but this looks much better. Basic tree. If we increase the ninth gene, then basic tree turns into something like this. If we decrease the fifth gene, then basic tree turns into something like this. If we increase the first gene, tree turns into something like this. Decreasing the ninth gene, we get less branches. Increasing the fifth gene, we see something like this. Maybe we can fix the number of branches. That way we will have a bit more structure, but yeah, we are not aiming exactly for this, but something like this. I think this looks fine if we do not have a lot of layers. If we increase the number of layers, yeah, it does not look good, but with lower number of layers, some specific configuration here, things look good. think we can work with this. Yep, it seems cool. And uh, full screen and yeah. Hello there. And yeah. If we add this thing back, then nothing changes because it's does not look good. Yeah, these lines do not look like organisms, they just look like lines. Biomorph. Yeah, let's just work with this. This is, yeah, something. We have added some what symmetry in some sense. That is fine. Yep. And here instead of this math.py.2, we will have angle DNA dot angles divided by 10 multiplied by math dot pi divided by 90. That is the maximum extent of the angle. Yep, and our organism has a little bit of character. Yes, yes, that is fine. That is fine. Now on to the second part, which is adjust aspect ratio. We have to adjust the aspect ratio of this whole thing. Yep. For which we can just find out what the maximum highest point is, what the lowest point is, what the leftmost point is, what the rightmost point is, and just get the aspect ratio. Yeah, we will have a function. Yeah, we will have a function which takes in an organism like this and converts and puts that organism into some box of like some certain shape. Okay, helper. Adjust box or adjust container.ts. Cons adjust container of the organism. This takes in lines which is of type line list. Import not red line but both cons adjust container equals both lines. This takes in lines whose type is a line list, and this also returns a line list. Let response is a empty list of type line list. Return response lines is declared but its value is not. Okay. uh, Let min x min y min x equals min y. Can we do this? Min y equals infinity. Infinity, we do have infinity, that is cool, but we cannot do this. Let min y also equals infinity, and let max x equals minus infinity, and let max y equals also minus infinity. Okay, and yep, we will go through all the lines for first line of lines. If line dot start dot x on if um, min x equals minimum of min x comma line, yes, min does not exist, makes sense. Math dot min min x comma line dot start dot x comma line dot end dot x. If we can give three things, we can give three things. Max x is max x max x. Mm. Substitute x with y globally, enter, and yes, here substitute may with max on the whole line. Okay, we have min x and min y. Okay, so let height height would be max y minus min y, and let width would be max x minus min x. We have height and width, and this function also takes in height and width, which is a number, and width, which is a number, and change this to be c height and c width, like current height and current width. Okay, and we need to give some buffer, some padding also at the corners. Okay, while maintaining the aspect ratio. Okay, if our organism has an aspect ratio of, let's say, 1 by 1, and our like container is something like this with a greater width, then we want our organism to be fully there with borders on both the sides, or yeah, something like this. Okay, let's say for our organism we have x and which is wrong, wait, we have y is here, x is here, we have x here, y here. Yep. And for our screen on which we want to present, we have x capital and y capital here, something like this. And yep, we want to put this here. Okay, x and y here, x here, x, y, x, and y. We must maintain this ratio. We must maintain this ratio, and if we decide to shrink all, yeah, if we decide to shrink all of the y of all of the x points by, let's say, half, we will have to shrink if x dash becomes x by 2, then y dash would become x dash by y dash should remain same, should be equal to x by y. So Y should also be shrink by the same amount. Okay, makes sense. Okay, so the amount should be same. It should be same. Okay, to maintain the aspect ratio. Okay, and if x is something and y is something, if for the organism, if it has greater x and y is smaller. Okay, so if the organism is like this and our screen is like this, then x is the deciding factor. Yeah, okay, whatever the bigger one is, that is the deciding factor. Okay. Yeah, and let factor equals 1 and if c height of the organism is greater than or equal to c width, then factor, we will fit the factor here. Yes, height is greater than that. Height minus, let's say, 5, height minus, let's say, 8, 10 pixel divided by, if we have a big thing and we have a small thing, x and x, you want to shrink every point. Capital X, we do have capital X. Small x is, yes, we also have a small x. Right. We also have a small x, and to project some point here onto this, some x dash and x dash, the ratio should be same. So x dash should be, or x capital X dash should be capital X by small x into x dash. Yes. Yes, cool. Okay. Capital X by small x. Okay. By small x, which would be C height. Else factor equals width minus 10 divided by C width. And now we have to go through all the points, all of the lines, and change them. Okay. Const line of lines res dot push line dot res dot push start x is equal to line dot start dot x into factor and factor end end. Cool. At the end, return the result. Okay. Okay, lines 1000 by 1000. Okay, before passing in the lines, adjust container, pass in the lines, and then height, let's say 500 by 500. And what do we have? That actually looks fine. Okay, shit. Hello. Yes, we are inventing, we are making progress, for real, bro. But I like the creamy keyboard sounds. Shit, you can hear the keyboards. Okay, there is a lot of background noise. Shit, you can hear a lot of background. Shit, my bad. I will fix that. Well, I like the current mic setting though with keyboard sounds. Shit. Okay, I will keep it that way then. Okay, look at this here. If I change this to say height, and this also to say height, and substitute 500 with width globally, and here if we say let height equals 500 and let width equals 500, that is something. And if we scale this, say 700 here. Okay, this is cutting off a little bit. Yeah, the scaling is fine. Yes, scaling is fine. Scaling looks cool. Yeah, it is cutting off. It is cutting off. The thing is cutting off. Height. If the height is too much, but the width is smaller, but for the organism, for our organism, width is going out of proportions, even though the yes. Okay, we have to make some changes. Components, not components, in the helper. Adjust container. We got our first titan with 2 squatted head and 4 legs. Yes, that looks like a titan. Beast titan. We have to change something here. C width, if height is greater, no, not on okay, so yes, the factor should not depend on absolute values. Yes, the factor should not depend on absolute values, but on not on absolute values, but on ratios. Okay, let's say okay, if either the factor is this or the factor is this. If the factor is this, let's start with the factor being equal to this thing. Okay, if the factor is this number, and okay, laptop is going to die. If the factor is this, and using this factor, If we scale, this factor fits the height but does not care about the width. But if we scale this for the width, and if this thing turns out to be bigger than the if this thing turns out to be bigger than the width of the whole screen, then we change the factor would be equal to width, this thing. And now we should be okay, even if we change this to some big number. Yes, the organism is not going out of screen, and that wait, it I think this it is still going out of screen. Now it is not going out of screen. And if we decrease the width to be very small, then it does not matter how big the height is. Okay. Okay, that is acceptable. Looks cool. Okay, so we have done both of the objectives for the day. Yep, bro, I used to draw triangles like this using compass and shade triangles. Yes, literally yes. After marking stuff like this and then making circles, it looks cool. What are you cooking? We are cooking evolution here. We have our own interface for evolution. Yep, interface for DNA. This is how our DNA looks like, and depending on DNA, we have a React component which takes in the DNA and makes the image of what an organism would look like with that DNA. Here this is an example DNA. Let's make 2 organisms, DNA 2, and here make DNA equals DNA 2. And what do we see? We see 2 organisms. And if we change some things in the DNA, we see changes in the organism. And now, now the next step is to get generations. On the whole screen we will get a bunch of organisms, and we can select the one which will go on to the next generation. And for the next generation there would be some changes in the DNA, and we would get different organisms asexually reproduced from the previous one, and we can select from that one which one goes further. We are acting as, instead of natural selection, we have the user who is doing the selecting. And at the end we can have some cool animals or something, organisms. But that, I guess, would be it for today. Sounds cool. And this idea I got from Mr. Richard Dawkins. He's amazing. His book is amazing. Here, The Blind Watchmaker. But these shapes are more complex. Look at this. This is what he was able to make. These shapes, and they look better than what we are creating. Yep. So he began uh, with some very small random shape, and he got some generation. He chose something and moved forward, 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 and at the end got to some shape like this, a spider or something, an ant. Yep, it looks cool. Research kit. Wait, breeding screen of the blind watchmaker program. Security check. Wait, I think they have the program online. Shit, no, this is just a screenshot. Yep, this is just a screenshot of the thing. Yeah, so we will have something like this. We have a bunch of organisms, we choose one and make a new generation, the next generation, and yeah, we just keep repeating that. Yes, that book is cool. That book is actually pretty cool. It would literally blow your mind. Richard Dawkins, The Blind Watchmaker. This will literally blow your mind. Yes, and you look at the simplicity of the process of evolution and the complexity that can come out of this simple process. Yeah, it is crazy. Okay, and I guess tomorrow we will continue and we will add the generation part. We did the two objectives for the day. Add symmetry. We did kind of added symmetry to these shapes. Symmetry along the, if we flip the whole thing on the y-axis, we have symmetry. And aspect ratio part was simpler than adding symmetry. We can just give in the height and the width in which we want to present our organism, and all the lines which make up the organism will change and fit in that height and width. Yep. And tomorrow we will add generations to this thing. Yeah, and I guess that would be 80, that would be the whole thing. After that we can add new features like adding DNA of an organism that you have created and storing it and maybe bringing it out later, and sexual reproduction at some point also, cross pollination or something. Find outward when you finish it. Yep, I'm having high hopes. It will look majestic for sure. Shit, I hope so. And the fun part is that this is this only needs front end, so I can just send the link to anyone and they can just use it. So yep, that is cool. And yep, that would be the end of today's stream, and thank you for being here. Bye.